Alright, we're back. We are COMP305 in the fall 2019 semester at Centennial, and it's week 10 already. We've got this week plus another 4 weeks left, and that's it, right? So we're kind of at the end today. Your beta was officially due, but I've moved the due date to Sunday at midnight to give you an extra day so that you can do stuff. Remember your beta, if you look at the document, let's just go there for a second. No, not that one. But if we could look at the document, we can see that what the requirements are for beta. If you scroll down to your project document, you can see that this is project part 5. It's 10% of your final grade as a group. All 3 levels must be functional, complete, and playable from start to finish. Now it says 95% complete. I know you guys have had a lot of competing assignments this semester. So if it's 80% complete, I'm okay. That means that most of your assets should be still your own or finalized assets, whatever they are going to be. Please have that ready. What I'm looking for 3 levels is including a start and end screen. So that means that there's 5 levels. Start screen, 3 levels, and an end screen. That's what you should have for this one, okay? One thing to note is that one of your levels should be a tutorial, right? That's what it should be. So that way people know how to play your game. The tutorial can be very simple, like pick this up, fight this, creature, some simple, UI. It does not have to be a quest system. You don't have to sit there and go like, okay, pick this up, check mark, you did it, okay, great, and then go to the next one, and here are these 5 more things you got to do. Not asking for that. That'd be awesome if you did that, but it's not required. Notice also that there is a live link to, or link to your live site. That is required today. Make sure it's up and live, or you update your live site. An updated game design document is required, right? So anything that you've added, new screenshots of your game, things like that, as well as make sure you give me the latest link to your Git repository. If you've changed Git repositories, please make sure that this is accurate, because I'm going to be looking at those things when I do the marking. Alright, so that's what's due today. Also, what's due today is a peer review. This is your 4th peer review. There's many of you who did not do a peer review. That's like an immediate 1% off. Some people also did not hand in their assignment number 2 for some reason, right? So if you didn't hand it in, please, it's better to put it in and get part marks than no marks, right? So please do that. That would be very bad. It would affect your average, for the course, if not for your entire the program. Okay, so all right, so that's that. So what are we talking about today? We're going to be talking about object pooling. So I put a couple things here. We're going to mention coroutines a little bit, some animation, design patterns, Singleton factory, and object pooling design patterns. Talk about what those things are. I've put some assets up on eCentennial that I'd like you to download if you haven't done that already. We're going to be working with the last project we did last week, which was Lesson 9, Part B. So let's do that. So I'm going to pull up that project. I'm going to pull up Unity Hub right now. Please do it with me so we can get the most out of it today. So here's Part B, or Lesson 9B. Again, you can find this up on GitHub. If you go to github.com/Centennial College /COMP305-F2019-Lesson 9B, you should be able to find this project. Okay? And if you remember last time what we did, we created, we made the use of different settings with scriptable objects, right? We removed our switch case from our game controller, which makes our game a little bit more efficient. And right now we're sitting at a game that kind of does the same thing we did before. However, it's using scriptable objects, which is good. It gives us more flexibility. So today, what do I want to do? Well, you know what? I don't know if you guys have noticed, but the game doesn't look menacing. Those clouds look like nice fluffy white clouds. right? So what I want to do is make the clouds look angry and red, right? But I don't want to do it just so that they're angry and red, and that's it. That's like a simple tint on the cloud. I want them to pulse red, and then go back to white and red. And in order for us to do that, we have to talk about a concept called linear interpolation. It's actually a math thing. I know it's a mathy thing, and math things are always freaky, you know, they freak people out. But does anyone know what linear interpolation is? I know it's a funny word, but usually the short form is LERP. How about that? Anyone know what that means? LERP. Yeah, it's a thing. Let's look up linear interpolation together so I can explain it a little bit differently. So if I look up the term linear interpolation, I want to look up a linear interpolation formula, and I'm using trusty Wikipedia here. Let's go down to the code. So it kind of looks like this. Now this could be code for anything, but take a look at this. You got two floats in this particular case, and this is the LERP function. Okay, you get two floats and a t-value. The t-value is your interpolation value, or your step. Think about this, your little step. Imagine you're moving from one value to another. Let's say, for example, from 0 to 1. But I'm going to take a small step from 0 to 1 of, let's say, 0.1. So I'm going to go 0, 0.1, 0.2, 0.3, 0.4, all the way to 1.0. I'm interpolating the distance between the 2 points, right, with a small step in between. Why is this good? This can create things like ease in and ease out. I can accelerate or decelerate. You can use a different t-value. It doesn't have to be 0.1. It can be 0.9 as an example. However fast or slow you want to go. And what it does is it allows us to smoothly move or transition or blend from one state to another state. I want to blend from a 0 state to a 1 state over a certain time frame. I want to linear interpolate, or LERP. It's a smooth way of moving from one value to the other instead of a discrete way of going from 0 to 1. I'm 0 to 1, right? That doesn't look natural, as opposed to 0, 0.1, 0.2, and I'm moving all those, kind of in a continuous way from one value to the other. So here's one thing that's really great. LERPing can be used for many different things. For example, I can linearly interpolate colors. I can go from one set of colors to another, right? For example, I can go from and if we had all of our color values, R, G, B, and A, all of them were normalized. Normalization means from 0 to 1. So values could be from 0 to 255. We've remapped those values where 255 means 1 and 0 is 0, right? So 0 to 1 is where 1 is 100% of 255 different options. We're going to move from 0 to 1. And I want to linearly interpolate each of the channels, R, G, B, and A, from one color to the other. Okay? So what that allows me to do is I can blend, I can move in from one color to the other, right? I can blend from one state to the next. So why is this good? It creates more of a smooth step between transitions. You can transition. You can create different kinds of motions that you want with by using linear interpolation. For today, what we're going to do with it is we're going to make it so that these clouds that we saw, these clouds here, right? And I'm just going to move back to my scene, the proper scene, which is the start scene for a second. There we go. Why is that happening? That's weird. Well, it's main, sorry. Let's try it again. So in the start scene, you can see that you have these clouds, and they're all white. But what I want them to do is I want them to pulse. I want them to go from a white to a red, angry red color, and then back, right? So I want them to linearly interpolate between one color and the other. And when we move back and forth, Unity has an actual function for that called ping pong, which actually allows us to go linearly interpolate from one color to the other, and then from that color back. Okay? Almost like a toggle, if you will. Maybe that would have been a better name. So how do we do that? First of all, we know we're going to change the cloud colors, and the cloud is actually a prefab. So if you look at the prefabs, here we are. This is just the beginning, because we're going to make the clouds look angry and menacing, okay? So the prefab right now uses a cloud material, right? And if you look at the cloud material, it's actually a material that's sitting in the materials folder, right? And if you look at the tint that's on the cloud material right now, you can see that the alpha transparency is at 128, which means it's 50% transparent. That's each of the clouds. What I want to do is through script, through code, I want to be able to affect each of the clouds that's instantiated so that they pulse from white to red and still maintain the 50% transparency. How do we do it? It's not that difficult. We have to go to prefabs, and if I go to cloud, and if I go to my script for the cloud, so cloud controller, in the cloud controller, which is of type monobehavior because it's attached to the cloud, what I want to do is on update, right? I want to be able to create this pulse, this kind of way of moving from one to the other. Now here's what I know. I know that we have a reference, we have something called the Sprite Renderer. And I can do this all at once. But what I'm going to do is I'm going to create a reference to the Sprite Renderer here. So I'm going to go down here, and I'm going to say something like, it's going to be private. I don't need to make it something that I have access to. We're going to make it of type Sprite Renderer. And we're going to call this Sprite Renderer. And what I'm going to do is, inside my start function, I'm going to say that Sprite Renderer is equal to GameObject.getComponent Sprite Renderer. I guess this gives me a reference to the Sprite Renderer that's attached to my game object. Okay, remember the Sprite Renderer, if you look at the game object itself, has a reference to a materials object. Look, there's a material object. So I'm going through the Sprite Renderer to get access to the material. So again, here's this. And then I can simply say that on update, every time it updates, I'm going to say that the Sprite Renderer, here it is, dot material, dot color. So the color of the material that's attached to the Sprite Renderer is going to be equal to a new color, right, that I want to interpolate. And the great thing about this is I can sit there and go like this. I can say color.lerp, linear interpolation, that's what a lerp is, from one color to the other. Take a look at that. There's two colors there, color A and color B, with some kind of step. I need color A and color B. For now, let's use red and white. So we're going to say from red to color.white. I'm going to see there's a problem with this in a second. With a step, remember the t value is that the steps, 0.1, 0.2, 0.3. I'm going to use time.time. So time step. And what this is going to do is going to create a new color every frame. But what I want to do is I want to ping pong between one thing and the other, right? So notice that there's A and B. And if we want to look at color lerp just for a second, so if I look at the script for color lerping, and I believe it is here. Here's what ping pong can look like between two floats. I can sit there and say, okay, I have a new vector float, and I want to ping pong the x value between 0 and 3, as an example, right? And there's also something that looks like this. Here's my lerped color, color.lerp, color white, color black, but then I want to ping pong my value from time.time to 1. And let me just do that now. So I'm going to go back to this. This is what I really want. So I'm going to go back to this script. So instead of time.time here, I'm going to ping pong the value. So I'm going to say like math f, which is the library, and I'm going to say dot ping pong, and it's going to be from time dot time, just like it says here, to 1. This is right from the Unity manual. Time dot time to 1. And what this will do is it'll create a way of me going from one value to the other, so from whatever the time value is to 1, and then back. It's going to go from 1 back down to thing. The ping pong is a great little function, so it actually does a lot of stuff for us, right? Where it kind of increments, it kind of does a loop, and it loops through every time ping pong is accessed. It keeps track of what the value of t is, the t value, and it kind of increments it or decrements it according to whether it's going up or down scale. So kind of really cool. So what this will do is create a new color, and it'll go from red to white, but we're going to see a problem. And let's talk about this problem in a second. Not a big problem, but a problem. So let's see what this does. If I go back to Unity, and if I run it, then now we get this. Okay, pretty simple, but you know what I don't like? There's no transparency anymore. It's gone, right? So neat, this is a good test, but what I want to do instead of having these color reds and color whites, let's make our own colors. So we'll make it half red and half white. Again, there's different ways of doing this. I've just chosen to do it this way. Private color, half red, and private color, half white. Again, I could modify the colors and change the alpha transparency when I come in here, but I'd rather just do it this way. I can say that half red is equal to a new color that is red, so that is 1.0f, and then 0.0 for the rest, with a 0.5 transparency for this one. And what I'm going to do is half white is the same thing. I'm just setting up my colors. Half white, there it is. And white is 1 for everything, and 0.5. So what is this going to do? It's going to ping pong from this value here. So red is pretty much going to stay the same, but these values here from green and blue are going to go from 0 to 1. That's what's going to happen. Okay? So we're going to say instead of color red, we're going to go half red, and then this one will be half white. I'm calling them half red and half white, so I know that they've got some alpha transparency. Okay? And let's see what that looks like now. So again, what my expectation is, we're going to pulse between one color and the other by using time.time. So now more of an angry looking cloud base. Yeah, sure. So very simple thing. We did like in 2 minutes, right? Really. But why is this really good? So imagine your player dies. Pulse between completely opaque and completely transparent. Sorry, I know. Let me put this over so you can see the rest of it. It looks kind of like this. I could also let's move this into 2 lines so you guys can see this better, like this. How's that? So yeah, so my player dies, and what I want to do with the player is I want to make it pulse. I want to kind of make it quickly pulse. Now I'm using time.time for the timing, right? And that's why it kind of moves in and out. I could also use a sine function, some kind of sine wave, where I kind of sit there and go like, okay, so the t value is going to be based on the sine I'm passing in there, or some kind of cosine value or something like that. I could also make my own time step. I could put this inside of a coroutine, but I'm trying to make it so that I don't use a coroutine at all, make it simple for you guys, right? So this is just going to pulse, so pulse the color of the clouds from red to white, okay, to make it look angry. That's what this does. So now that we have a reason to make the people feel, your player is going to get feedback, hey, something's wrong with those clouds, right? Before they look like nice fluffy clouds and you're supposed to be able to pass through them, but somehow you hit them and you're like, you know, you get this thunder sound, you know, happening, right? Yeah, we don't want that to happen. We want the clouds to be radioactive clouds in a post-apocalyptic world, and your poor planes running through them, or something like that. You could also make it so that there's, I don't know, some kind of lightning effect later on, where the clouds are animated and they kind of use lightning. But for now, we're going to use this very simple way of doing it. So questions around linear interpolation. Again, two values. You have two values you're moving from. By the way, you can linearly interpolate almost anything if you think about it, because it's just data, right? So if I want to move from one color to another, one position to another, one sound volume to another sound volume, you can do it for blending, mixing, all that kind of stuff. It's a great way of doing things, and it's more natural than a discrete step from 0 to 1, right? That's more of like a, think about almost like the boxy kind of wave, right? As opposed to like a nice smooth slope. Make sense? Great. Now that we've got our reason for making our objects explode, let's download our new assets. So again, up online, if you look at our week, we have assets 2. Here it is. Please download assets 2. This is inside of your week 10, right? And I've already done that. I'm going to go back to my downloads, and I've got assets 2. And I've got a few things. I've got a bullet that I'm going to use probably next week. But I've got all these explosion assets. I'm just going to copy everything here. There we go. Copy it. And I'm going to go to my desktop where I have my Unity projects. And I'm going to go into week 9B, into my assets. And I'm going to go into my textures and paste them. There we go. There's my assets. What Unity is going to try and do right now is import them. So if I go to textures, you can see now that I have these big explosion textures, yeah? Alright, so now this is where we get into some interesting stuff. I want an explosion. At the beginning, what I wanted to do, and this is part of the object pooling example, okay? But we're going to stop by making the explosion first. Remember how we made an animation? Pretty simple. We know this by now. We're going to take the whole explosion texture like this. I'm going to drag it into the scene. This is a quick way of doing it. I've got myself an explosion. I'm just going to call this explosion.anim. And what it does is it creates a couple things. I've got, when I pulled it in, it's giving me a big explosion animator controller as well as an explosion clip. Let's take those two things and pull them into my animation folder, animations folder. In my animations folder now I have those two things, a big explosion one and an explosion. So the clip is an explosion clip, that's what it is. And this is the explosion animator controller. Let's rename this one. So explosion animator controller. And this is my explosion clip. Okay, explosion clip and my explosion animator controller, yeah? So what does my explosion look like? Now right now you can't see it. Notice you can't see it. Why? Because order and layer, remember we're looking at 2D objects. 0 is the ocean, 1 is the island, 2 is your plane, 3 is the clouds, 5 is probably going to be your UI, something like that, right? So I want to put it either 2 or 3, and my thoughts are it should be at the same level as the clouds. Okay, so I'm going to put it at 3. You can put it above the clouds if you want to, but 3 is fine. So now you can see it. And if I run this thing right now, you can see what happens is it just resolves. And it keeps looping over and over again. Okay? What I want this thing to do is my big explosion, we'll rename this to explosion, because we're going to make a prefab of this in a second. Here's my explosion. And I don't want my clip, my loop, or this clip to loop. I want it to play once. So here if I click on the actual clip and I go to loop time, I click this off, and when I run the scene again, it literally just does this one time. However, my explosion's still in the scene. Wouldn't it be nice if the explosion, when it's done doing its own little animation, it destroys itself. That would be nice for the first iteration of our explosion. So it does its animation, then bye-bye, it's gone. Also, it's a little fast. And where you can get that, if you go to the explosion animator controller, notice it gives us little state machine. Here's a little state machine. And if you notice the state machine, if I click on the actual state, this explosion state with a lowercase e, notice on the right, my speed is 1, which means it's happening at 60 frames per second approximately. Let's make this 0.8, just to make it a little bit slower than 1. Okay, 0.8. And if I run it again, then you can see that it's slightly slower, but not much. Okay, so let's try that again. You can see it come and play. There we go. Slightly slower, almost more retro feel than it was before. One thing I also don't like is the fact that it's completely opaque. I wouldn't mind if it was partly transparent, which we'll change later. So yeah, so this is pretty cool. We've got an explosion, but now what I want it to do is I want it to resolve itself. How do I do that? And remember, I'm also going to play a sound. So the thing's going to play a sound, and it's going to be instantiated. Now we're looking at bad things happening. This is the first time we're kind of instantiating something that we're not reusing. We're going to fix this, but one step at a time. So what I want to do is just make the explosion work. Okay, so here's my explosion, and it's going to come into being, and then it's going to destroy itself. Now, there's a couple ways I can do this, the destruction. I can instantiate it, and I can destroy it inside of a coroutine. I can wait for a certain number of seconds, wait for seconds in a coroutine. A coroutine works as a separate thread. We talked about this before. And in that separate thread, the coroutine can wait a few seconds, or part of a second, maybe 0.2 seconds, and then when it's done, it can just literally just destroy itself. However, wouldn't it be best if it was exactly when we're ready to change states? For this, we need another state. So here we have an explosion state. Let's make a new state, an empty state. And I'm going to call this empty state finished exploding. Here's an empty state. There's no clip associated with this state. Okay, it's just a state machine. Finished exploding. That's my state. And I want to make a transition from this state to this one. And it's going to use exit time. So what's going to happen is I'm going to explode, and then it's going to move into finished exploding. When it gets to finished exploding, or when it's transitioning, I want it to destroy itself. And I want to do it in here, not in some coroutine or manage manually in some code, in here. So how do I do that? Well, there's a couple things, first of all, that we have to think about. How is it going to know when this is done, when the explosion state is finished? Well, there's a really cool thing you can do. On the right, you can see if I click on the state, there's something called add behavior. Let's go there. And I'm going to click on add behavior, and it's asking me for a new script. I'm going to call this my finished exploding behavior, right? That's what it's going to be called, right? That's the new script that I'm going to make, finished exploding. I'm going to create an add. Now, by default, it adds it to the wrong place. I'll correct that in a second. But this script, this finished exploding script here, if I double click on it now, I want to talk about this a bit. This is a different type of script. It's not a mono behavior. It is of type state machine behavior. This is new. State machine behavior has some default methods that are part of the class, the properties of the class. Notice that there is override public void on state enter. So I can do something when I enter the state. Override public void on state update. So when I update between one state and the other. And then there's something called on state exit. Aha! When I leave this state, I can do something. This is what I want. There's other ones too. I'm just going to uncheck these ones. So I'm going to come back from them being kind of commented out. And notice what I have. I have animator. I have access to the animator. I have access to my state information as well as my layer index. And this is the layer of the object. Okay, so these are the three things I have. Remember, this is not mono behavior, so there's only certain things I can do. Here's one thing I can do. I can say that I want to destroy the game object that's attached to my animator. So I can say that animator.gameObject is what I want to destroy. So that means that when I'm done and I'm transitioning from the explosion state to the finished exploding state, right, I'm going to call the destroy function, which is a mono behavior function, that's going to kill my game object. If all things go well, it will remove the game object from the hierarchy automatically when it's done. Any problems with this? Okay, let's try it. So run, and it explodes, and it's gone. Let's try it again. Watch. Look over here, and it's done. So it did it. It cleaned up my explosion. Once it was in play, it used the animator controller to move from the explosion state to the finished exploding state, and when it moved, it triggered an event, or we say it raised an event. We're using the observer pattern here in the background, right, or the event system, to see or detect that this on-state exit event has been raised or triggered. And once that's done, we're moving from one state to the other. Then we just destroy the game object that's attached to the animator, and we're good to go. Guys, way more efficient than using a coroutine or something else. We use a little script attached to the state. Questions around this? Nice. We're not quite there yet. Now what I want to do is it would be nice to have a sound that's associated with my explosion. And I'm going to go up online for this. So I've got a sound that I kind of generated online. You can pick your own sound, but I've got this one, and here's the sound that I generated. Okay, let's try that again. There we go. I just generated this with bfxr.net. You can also use chiptone. I also tried it with chiptone, so here's my chiptone version. Okay. Maybe not. But my chiptone version actually worked before. I think it's because I'm connected to this projector and everything else. But at the end of the day, you can use different ways of creating your sound waves. I like the BFXR version anyway, which kind of sounds like this, right? So that's what it'll sound every time. I'm going to export my wave. It's kind of retro. I'm going to export my wave file so that it sits inside of my project assets audio. We're going to call this explosion.wave. Explosion. There we are. Again, just generated online there. And if you look now inside of my assets, I have an audio asset called explosion. We can actually test this asset out by trying it out. Right, there it is in Unity. Okay. And I want to attach this asset to my explosion game object. So again, in order for me to do that, I'm just going to minify these things and add a new audio source. And I'm just going to drag and drop my explosion clip into my audio source, and it's going to play on awake. So when I create this prefab, or when the prefab enters the scene, it's going to play the explosion sound and then destroy itself. Let's try this out. Perfect timing too. Look at that. Ready? Okay, pretty good. Now we want to make this into a prefab, this explosion, right? So I'm going to take this explosion, I'm going to pull it into my prefabs folder, the way it is for now. And what I want to do is I want to remove this, because I don't need this anymore, and I want to pull this explosion in when I need to. So let's try this out. So running it, no explosion. I pull the explosion in, right? Looks pretty good. Right, that's what it's going to look like, and it appears above everything else. Okay, so that's what the explosion. So it comes in, generates a sound, then destroys itself. Okay, nice and easy. Okay, where we want this to work, how we want this to work, is we need to generate the explosion when we have a collision. Right now, our collision detection is on our player. The player uses the game controller, this thing. Our game controller houses all of the sounds as well as references to other prefabs. So let's just use the game controller as an asset list of prefabs that we're going to use. Again, there's different ways of doing this. You can certainly do it a different way than this. But let's use the game controller. So on the top there in the game controller, and this last day we kind of implemented our scriptable object, I'm going to use a new prefab called explosion. So it's public game object. We're going to call this explosion. There it is. And I need to make a reference to the explosion game object. So again, I'm going to go to my game controller, and I'm going to drag and drop a reference to my explosion game object from the prefabs folder into my scene. Okay. With this, I need to update my prefab because I've changed my prefab from my game controller. So let's do that. Let's apply to all. So all the scenes are going to have the same references. And now I have a reference to my explosion asset in my game controller. And it's a wonderful thing. Okay. Now, what I want to do is I want to use my clip. When I have a collision, I want to place my explosion wherever my ship was when it hit the cloud. So let's do that next. So again, I'm going to go to my player controller. Let's go to player controller. So I'm going to go to my scripts. By the way, we have a problem. We have this finished exploding script I just made. I don't like it here. I'm going to put this back where it belongs in my scripts folder. That was the finished exploding script that we made in our animator controller, right? And in my scripts, I have a player controller. Here's my player controller script. And remember, we already have access to the game controller up here. And down in my collision detection algorithm, which is on trigger enter 2D, I have this thing where game controller lives. Well, I just want to do something like this where I say game controller dot, and again I want to play that sound, which is it's called my explosion. I want to access my explosion. I want to instantiate it right here, right? So the way to do that would be I want to instantiate my game controller explosion, right? I want to put it, where do I want to put it? At my transform.position with quaternion identity, which is going to basically make it so it kind of puts it in place without any kind of rotation. So I'm accessing the explosion prefab that's nested inside of my game controller. I'm positioning it, the explosion, when I hit, wherever I hit, it's going to position it there, and I'm not rotating it. That's what this means. Guys, we can do rotations too. If you really want to make your explosion rotate to make it more interesting, you can do that too if you like. Right? That's going to be inside of your explosion script somewhere, if you have something like that. Right now we don't. Are you with me? So again, we made an explosion prefab. The prefab comes into play. It destroys itself, makes a sound, then destroys itself. And now what's going to happen is we're going to instantiate it when we have a hit. And we're going to talk about good things and bad things about this. Okay? Now that we have this part, how does this look? So we've instantiated our explosion when we hit a cloud. Only when we hit a cloud. Alright, cool. So we'll make it go. So far we're good. Let's start the game. Let's see if we have any issues. So far we're good. And we get hit. Looks pretty good. Right? And we're done. Does that make sense? It's nice and easy. However, good feedback for the user. We're getting an explosion as well as the other sound together combined, so it's pretty good. Great thing about that is it makes more sense now. We're getting good feedback. And if I was going to play it with my little trusty controller, right? Let's try this on. There we go. I'm going to restart the game again. So let's see how that works. See if I can avoid it. With my controller's got more control.
Yay.
Oh boy. I don't want to get greedy here with these angry red clouds. Darn it.
Yay.
Oh boy. as you can see, it's not bad, and the angry red clouds give me a look of there's definitely danger in the sky now with these angry red clouds. Don't know why they're red and angry, but we know there's a problem. The player should avoid the clouds at all costs. Okay? So here's the problem with this system that we just created. We made a nice system. Explosion, prefab. Yay! But we're going to have something called memory fragmentation. Why is that? This is what we've been avoiding this whole time. We've made things that we reuse. Clouds we reuse, islands we reuse, but we've never had anything like a explosion or a bullet before. We've been talking about it, but what I'm going to show you can apply to anything that you want to reuse. And I highly recommend we reuse objects instead of instantiating and destroy them. Because what happens is you get this idea of memory fragmentation. When you're instantiating, it causes a bit of CPU jump, right? And then you have some stability, and then when you destroy, it releases things back into the memory pool, and then you get some CPU jump again. And what this does is it causes memory fragmentation and also reduces your, it changes your performance. Now, for this small amount of explosions, meh. On my computer with an i9 and 32 gigs of RAM, who cares? I'm not going to have a feeling with it, right? But imagine if this is a web game, or if this is working on a mobile device, right? This can have a serious impact on memory, right? So what we want to do is use a design pattern to help us. So there are 23 design patterns for object-oriented programming that are out there. They've been made by a group called the Gang of Four back in the day, in the 90s, when they basically talked about, hey, listen, there's a lot of stuff that we're reusing over and over again. And I've talked about design patterns in the past, right? Now, for you as programmers, I'm not going to tell you that I expect you to learn every design pattern, but there should be some basic ones as game programmers we should learn. Game Programming Patterns is a book that Robert Nystrom wrote. Politely, he put it up online for everybody. So if you actually go, I've got the link on GitHub. On eCentennial. You can buy it if you'd like to, download a sample, get the ebook, or just go to the web version, which is right now, and it's free. One thing we want to talk about is this optimization pattern that we want to learn. So different kinds of patterns, creational patterns, behavioral patterns, sequencing patterns, a bunch of different kinds of patterns. These patterns help you when it comes to designing your game. And why? Because they're very common patterns that we use over and over again when we develop games. Okay? So we want to use an optimization pattern called an object pool, right? And the object pool pattern, the way it works is we have this idea of memory fragmentation. So we allocate memory on the heap, as an example, and then we delete stuff, and we're doing this in real time. And what ends up happening is you're going to reallocate memory. And then what are we going to do? We can't fit this in here, which means we're going to have to allocate more memory. And we get this memory fragmentation, which means we lose memory. There's areas we can't fit in new, the objects we're kind of creating because we're destroying and recreating them. And so it's better for us, instead of having this memory fragmentation problem and also performance, right, to have an object pool that we reuse. Now, one of the things he does in his book is he also gives us some code hints. Now, even though this is written in C++, which I think is great, he gives us some sample code to look at. And he says, look, this is a way we can do it, right? One of the ways we can do it is we can create, here he's giving an example of a particle, but what we can do is we can create a structure for the particle. So basically we create a container, a collection, that we can house our objects, and then what we can do is we can reuse these objects as opposed to us instantiating and destroying. This is bad. And also think about it like this. If I instantiate and destroy many objects, example in a bullet hell shooter or something like that, I will get inconsistently good and bad performance over time, right? Especially if I have multiple players playing at the same time and a bunch of stuff like that, right? I don't want that. I'd rather have, like I said to you before, consistently bad performance than inconsistently good and bad. Obviously, consistently good would be better, but I'm saying it's better just to have consistent behavior somehow, right? So again, he's giving us some code hinting, and we're going to come back to this book again. But the idea is we need some kind of structure in order for us to house our bullets or our explosions or our islands or whatever game object you want to house. Okay? And then what we want is, we want us to be able to, you know, kind of build a pool of objects, get an object from the pool. When I'm done using it, I want to return the object back to the pool. Okay, I want to release it back to the pool. Okay, so it's not quite what we've done so far with our islands. Our islands are very simple because when they leave the screen, they just go back, and we only have 3 of them. We never have any more, right? Or 1 island and 3 clouds, let's say. But what about if I need 50 bullets? Do I want to instantiate them and destroy them over and over again? Again, memory fragmentation is a bad thing. So let's do this thing. Let's make I want to make an explosion manager that manages and controls all the explosions. I'm going to pre-allocate 10 explosions, let's say, for now, right? And I can allocate as many as I want in the future. Now, I want to talk about collections before we move on from this example. There's different kinds of collections that I can use to house my memory, my pool. One is an array. I can use an array. The problem with an array is it's indexed. So I have to kind of do array management. One of the things with an array, for the most part, is it's immutable. Once I load that array up, when I instantiate it, I can't change the size of that array again. And this presents potential problems for me if I want to be flexible in generating new stuff throughout the lifetime of my game. Perhaps chances are I'm not going to, so an array could be used just fine. The other option is a list. A list will give me some flexibility in terms of use. It'll also appear inside the editor in Unity. On the bad side, when you pull an object out of the list, you have to manually track that you pulled it out and manually put it back. Okay? There's 2 other structures that you might have heard about, and you're going to learn about in, I believe it's COMP305. I'm saying that with a question mark because next semester, if you guys are semester 3 students this semester, next semester you're semester 4 students, you're going to take an Algorithms and Data Structures course, COMP354, if I'm not wrong. And that COMP354 course, you're going to have things, we're going to talk about things like stacks, queues, different kinds of things like that. What I recommend for this pattern is a queue structure. So think about what a queue is. A queue in real life is a lineup, right? And a lineup, what it does is when you line up for, you know, to pay for groceries, or when you line up to get money from the ATM, or when you line up to go to a concert or a movie, it's really first come, first serve. The first person in the line is going to get into the movie or get access to the ATM or get, you know, check out his food or whatever he's going to buy or she's going to buy first. So first in, first out. That's the queue structure, right? We on queue to add an item to the queue, and we dequeue to remove an item from the queue. Those are the keywords we're going to be using, on queue and dequeue. Okay, I'm going to show you these things. There's also a stack structure that we can use if we really want to. The stack is like a stack of cards. If you're a card player, play Magic the Gathering as an example, you have the first card, you put another card on top of it, it adds to the stack, and the stack works like last in, first out. So the top of the stack is the things you're popping off the stack, and you're pushing stuff onto the stack when you want to add things to it. Push and pop. It's okay, but it doesn't quite do what we want it to do. The queue works better. First in, first out. Whatever's the first item, the next item for that we have up, we would use that one. However, one thing to note, disadvantage of using a queue or stack or an array, it will not appear in the editor in Unity. The only thing that appears in the editor in Unity for the most part is lists. So just letting you know this. But management of a queue is much easier, and we're going to use that one. So let's create our structure. One other thing to notice is we have a game controller. I could certainly create another empty game object called Explosion Manager, all right, and then attach an Explosion Manager script to it. Then get a reference to the game controller from it. But you know what? We already have a game controller, and it's kind of in what we're going to be using. I'd like to make another script to keep it separate, because we can always attach another object later, like that script to another object if you want to. But I'm going to use the game controller as the main game object that I'm going to attach the script to. And it's going to be of type monobehavior today. So here I'm going to make a new script, create new C# script, and we're going to call this explosion manager with a capital E, capital N. I'm going to double click on this explosion manager. We're going to run into some problems, and you're going to see some of the common problems you're going to run into. One, all right, I need a reference to my explosion. I need a reference to it. I have it in my game controller, which means I need a reference to the game controller so I can reference the explosion from it. And I'm going to do this in a kind of an interesting way. I'm going to do it more of a private thing. So instead of getting a public drag and drop, I'm going to do private, and I'm going to call this game controller. And I'm also going to get a private game object called explosion. I want to get those two things, okay? So these two references I definitely need. And in my start function, what I'm going to do here is I'm going to say, all right, well, my game controller is going to be game object dot get component game controller. That's an easy step, right? So what this does is it actually looks at the object that this script is attached to, which is the game controller. It's going to be the game controller. I'm going to get a reference to the game controller, and then from there, I'm going to say that, well, explosion then is just going to be equal to my game controller dot explosion. So what this is going to do is going to get the reference that I already have for my explosion from my game controller, and then make a reference here inside my explosion manager script. So now I need to make sure that in my game controller, I'm just going to hide this thing. I want to attach my explosion manager script to my game controller. And so far so good. It's going to look at game controller and get a reference to the game to the explosion. Cool. Are you with me? Next, I want to create my structure. So I need a structure to house my pool, remember? So I want to make a private queue. This is what a queue looks like. QUEUE, right? Of type game object. And it's going to be called explosions. Multiple. Every time we have a collection, we try and name the object with an S at the end to signify it's plural, more than one explosion, right? That's a convention that we're using. So our explosions queue. Now this declares a queue of type of game object, but we need to instantiate it because right now we need an empty container to house all of our explosions. That's the next step. So here we're going to instantiate a queue of type game object. So this is step 2. So we're going to say that explosions, if I can spell, is equal to, and notice it gives me, my code hinting gives me this. That's what I need. This step instantiates a queue. Now, in Unity, if you do this for the list, you don't have to do this. Unity will do it automatically for you, but we're going to talk about how that might be bad anyway. So this ensures that you have a container that's ready to accept new explosions. Next, we need to build the explosions. We need to build up that container or fill it with explosions, right? So what we want to do is we're going to say, I need to know how many explosions, and I want to give access to the editor for that. So I'm going to say something like a public integer that I'm going to call explosion number. I'm going to set that by default to 10, let's just say. Okay, so 10 explosions by default. And what I want to do is I want to make a for loop that uses explosion number, right, to count, and then I want to use my explosions. Oh God. And I want to onQueue an item of type explosion, but I need to instantiate that object, which is of type explosion, and add it to it. And this is the structure. This is the way you do it. Now, there's going to be a problem here. And we're going to see this in a second. Okay, so cool. We did it. You instantiate these explosions. They come in. It's added to the pool. Okay, let's just see what happens when I do this. We're going to see a couple of problems here when it happens, okay? Are you with me, first of all? Do you understand what I've done? So here, again, I've made references to my game controller and the explosion prefab, right? That's what this is. Explosion prefab, right? And here we made a container of explosions. So this is a collection to house the explosions, right? Number of explosions are there. Here we make our references to game objects, right? And scripts. Oh. We instantiate the queue, so we basically create the container. Here we build the pool. That's what we do here, right? By adding or on-queuing instantiated explosions. Okay? Cool. Let's see what it does in real time, right? So here, take a look at this. Run it, and then that's really loud, and all the explosions at once, and they disappeared right away. And wow, that was terrible, right? But it worked, right? It kind of made them all, and then now they're gone, right? That kind of defeated the purpose. I mean, we made all these explosions, and then they went away. So what we need to do is a middle step. So yeah, this is good, but I'd rather do this. I want to rather say var. Let's use the var keyword. I'm going to call this new explosion is equal to this instantiate stuff, right? And then I want to on-queue this new explosion, but not before I set the explosion to inactive. So I can say that new explosion dot set active is equal to false, which what it's going to do is going to create the explosion, but not set it to active so that it won't play. So now let's see what happens when we do this. This is just a few steps. I could have done this all in one line, but it's okay. It's not going to save you any more time or efficiency to put it all in here. Okay? And so what does this do now? So if I go to it and I run it now, you can see that I'm going to have a bunch of explosions. These are all of them that are pre-allocated. Look, here they are. They're ready for me to use. I can't use them. I have no way of using them, but they're there. And man, this is terrible. Look, it's going to clutter my hierarchy. What a pain in the ass. I don't want this to happen. That's why it's not meant for kids, because I just said ass. Anyways, and then I'm going to be, you know, I want to take all these, right? And I want to put them somewhere, right? So a great thing to do is create a little container for my explosions. Now you can call this whatever you like. I'm just going to make a new empty prefab that I'm going to call explosion container. Empty game object, right? My explosion container is going to be reset, so I'm going to reset it to like 000. And what I want to do is, I'm going to make this a prefab. Follow me here. It's nothing. It doesn't do anything yet. But this explosion container, what I'm going to do is I'm going to use this one as the parent container for all my explosions. So when they instantiate, they're going to instantiate inside of here, as opposed to freely in the hierarchy somewhere. Because freely in the hierarchy, that just sucks. But here, containing them in here, I can marshal them a little bit. At least I feel I can. So what I need to do that, because when I make I need to kind of have a reference to this, so I'm going to make another public. And it's going to be of type GameObject. And I'm going to call this the explosion container. Alright, so my explosion container, which is a reference to my explosion container. So in my game controller, I have a reference now to my explosion container. I'm going to drag and drop from my hierarchy into here. I need to do this other places. In fact, what I could always do is pull it from here, but I'm doing it here like this. It's fine. I'm going to apply all, and I need to add my explosion container to the other scenes. Please remember this when I do it. I got to go back to those scenes and add them in there because the other scenes don't have an explosion container, but they will have it. So what I want to do now is I want to make each explosion to be placed underneath this explosion container prefab. How do I do that? Well, here's when I make it. I set it to active to false, and before I on-queue it, I'm going to say one of these things. I'm going to say that my new explosion dot transform dot parent is equal to my explosion container dot transform. So what this says is like the parent transform for me, my parent object is going to be the explosion container. So not explosion, but explosion container, Tom. Explosion container dot transform. Make sense? So it says that every explosion is going to have the explosion container as its parent. Set the parent to the explosion container. Okay? Now let's try it. So I run it, and yeah, look at that. Automatically, it's nicely organized. I know a lot of you like to see that. Hey, this can work for bullets, clouds, islands, whatever, enemies. You can organize them in their separate little containers, right? And furthermore, you can have a scene container that contains all, or I don't know, some other object container that contains all of these. An explosion container, an enemy container, a bullet container. And so you can have them inside of other containers so that, you know, your hierarchy doesn't like jump like this. Right? Like, look, I have 3 clouds in the scene, and it's like they're taking 3 spaces. Why? Right? Other real good reasons for using an explosion container is if I really want to move every explosion around, I can do that by just moving the explosion container around. So there's advantages to that. And I can also delete them. I can also turn them off, all the entire objects, everything that comes into it, by just switching off this little container. It's pretty cool. Alright, cool. So we've done all of this. This is great work. But we need to organize ourselves a little bit better than this. I know that this is something that shouldn't be right here. This stuff kind of creates stuff in my start function, but it'd be nice if we organize ourselves by doing one of these. So I'm going to right click, and I'm going to go to Refactor Extract method. And what this is going to do is it's going to allow me to make a new method called build explosion pool. And that is more descriptive. So here we go in, we do some nice things like this. Right, where we set references, instantiate a queue of game object, build the explosion pool, which is done down here. Okay, cool. We're pretty good now. However, we need ways of getting a bullet from the pool and returning a bullet to the pool without destroying and instantiating. Okay? Now we're going to have some issues, and we're going to talk about methods. One thing I don't need is update function, so I'm going to get rid of it. Remember that any kind of life cycle functions like awake, start, and update that are unused, that are inside of your code, take up cycles. So you know, they're computationally expensive to have in there. If you're not using them, remove them. Okay? So we need 2 functions. One, public function, which returns a game object, which we're going to call getExplosion. Okay? And there's going to be another public function which returns void, and that basically resets explosion. Reset explosion. And we're going to return the explosion back to the pool. So these 2 functions. So one that gets an explosion and returns an explosion, and another one that resets the explosion that I passed back to it into the pool. So from a getExplosion perspective, how will this work? This means that I'm going to dequeue. So I've on-queued to add to the queue. I'm going to dequeue to remove from the queue. So I'm going to say that my returned explosion, follow me here, is equal to explosions.dequeue. Dequeue, what it does is it takes the last or the first, remember first in, first out, the first explosion in the front of the queue, the guy who's waiting to get his money, all right? He's a soldier waiting to explode, basically. These are the explosions. They're waiting to explode. And I'm getting them. I'm going to set it back to active. So I'm going to say that returned explosion dot set active to true. So I'm setting it back to active. I'm enabling it, basically. And then once I enable it, I'm going to return it. So what this does is it returns the explosion from the queue back to the calling function, whatever I need it, okay? On the other side, when I'm done with the explosion, so for example, when the explosion's finished doing its animation, I want to return it back to the pool. And the way that would be done is, I get the explosion, I want to set active to false, so I kind of set it to false, and then what I want to do is I want to on-queue it again. So I'm going to say explosions.onQueue explosion. So I put it back in. So this recycles, this system removes and adds back the explosion to the queue. So it's almost like this turntable of explosions that go in and out, right? There's stuff we're still missing, and we're going to add to this in a second. We have a problem, and it's a pretty serious one. Okay? We'll talk about this in one sec. So, yeah, I want, remember we had this little finished exploding thing, which is in our scripts. So in our scripts, we have this finished exploding little code, and we're going to say that, well, instead of destroying, I want to reset my explosion. Yeah? Okay, oh boy. Can you see a problem doing this here? Destroy is okay, but what about accessing the explosion manager inside this and resetting my explosion? How would that be a problem? It's a terrible problem. Why? Because state machine behavior is not mono behavior, which means you cannot make references to other objects here, right, as easily. I'm going to have to find them somehow. They're going to be in the resource folder automatically. It presents a real issue. And hence, here is a great use for the first pattern we're going to be talking about today, which is the Singleton design pattern. So going back to the book, he presents this idea of a Singleton pattern. And if you look here, it's a design pattern that's very common. The Singleton pattern, what it does, and this is coming from the design patterns book. Remember, there's a design patterns book that he's using to basically morph or use for our purposes for game programming design patterns. And what they say in the book is ensure a class has one instance and provide a global point of access to it. Okay, that's his way of looking at it. So think about having access to a class that we only use once. So one of the ways he does this, and again, he uses some C++ code. I'm going to zoom in here so you can see it. So here's a C++ code. He says, well, look, we want to make our constructor private. That's one of the first things we do when we make a singleton, which means that other classes or other methods that try and call this class can't instantiate a new type, another object of that type of class. No new instances. There can only ever be one instance. There can be only one, just like, Highland. Anyways, so think about this, right? I know it's a geeky reference. But the other thing is that we have a static instance of the type. Now, this is a pointer, in this case, from C++, but who cares? Again, this is just, think about this as pseudocode for now. It's a instance, a pointer to the instance of this particular class, and it's static, private static instance. That's what we need to do for C++. And the same thing goes with C#. We need a public static instance function that accesses the instance. If the instance does not exist, then we use the new keyword to allocate memory and create the instance. Otherwise, we just return a pointer to the instance that's already in existence, which means we only create ever one instance when this function is called for the first time. Okay? Let's do it. So I want to do this, which means now we're going to go back to my explosion manager, and I need to change this into a singleton pattern. I don't have to. There's other ways to do this, but hey, it's fun. So this is singleton design pattern. Example. How do we do it? So again, we're going to follow the process. So one of the process parts is make the constructor private. So we're going to say private. The constructor is of type explosion manager. Explosion manager. So we have to make a private explosion manager constructor. Okay. By the way, you can put this on one line. It's okay. Style-wise, it may not be cool, but this is your private constructor. Private constructor function. Okay? That's what this does. Next, once you've made this private, the only way this thing can be instantiated, well, it's not the only way because it's mono behavior, but the only way that it can be instantiated under normal circumstances in C# is if you somehow use the getInstance method. We don't have one. We need a private instance member, private static instance of type explosion manager. So it's returning an instance to its own type. We're going to call it instance. So this is where the instance, a reference to the instance, is going to be stored and returned from. Next, we need a public static reference to a function that we're going to call getInstance. That's going to return an instance to this thing, explosion manager. getInstance. Yeah? Are you with me? This getInstance function is going to return a reference to the explosion manager. If we don't have an instance, if underscore instance is equal to null, then we're going to say that instance is equal to a new explosion manager, and we're going to return that one. Otherwise, if this is not true, just return the one we already have. By the way, you can write this in different ways. And this is your singleton instance. Okay? So singleton, if you're going to be asked this on an interview question, it's a construct that exists globally inside your application. You can only ever create an instance once of this construct, which you can reuse over and over again. It's great for things like managers, like texture manager, a bullet manager, something that you're going to use once, an audio manager, a system. All right? It's bad because it's a global variable. Okay, at the end of the day, you don't want too many of these. You want only the ones you need for systems to be in place. Okay? So positive and negative. Okay, then now that we have this as a singleton, we've kind of completed the singleton pattern. Again, step 1, make it private, a private constructor. Step 2, create an instance that's private static. Step 3, create a public static singleton instance that returns the instance itself. And now we're good. So how does this good? Because if I go back to my finished exploding thing, I can do this. I can say that, well, guess what? I want to access my explosion manager dot get instance dot, and I want to return. Here's something. I want to return my, or reset, if you will, my explosion, and I'm going to pass in the explosion that I already have, animator dot game object, back to the pool. That's what I want to do, and I don't have to use destroy anymore. So destroy, not going to happen. I'm going to take my explosion, I'm going to get an instance to my explosion manager, which is a singleton, and I'm going to return back through the reset explosion function the explosion that I just used. Yeah? But here's the problem. When I return it back, I'm already in a different state, right? My explosion, if I go back to Unity here for a second, and if I go back to the animator controller, you notice that there's only a couple states here, right? I'm already in this state. I need to get back to this state. Because if I'm here, I'm always going to be here. It's never going to go back unless I tell it to. So how do I go back to this state? Right? I need to play it again. That's what it is. I need to play this explosion one more time. Yeah. Explosion manager. For the, you want the singleton? So here's what you need for the singleton, right here. Questions around the singleton before I move on. So why a singleton? It's like a static class, but not. And what it does for us is it only allows us to create one instance. Now, I gotta be honest with you and tell you that mono behavior messes this whole process up. Why? Because in the background, if this was a list, it would create an instance for you anyway, whether you like it or not, right? So typically, when we want to make a true singleton, we remove mono behavior completely. We don't attach my explosion manager to a game object, and we let this float free as a non-mono behavior type class. By the way, scriptable objects are okay to make singleton as well. All right, cool. So yeah, we did this. Are you good now? Okay. So now that we did this, this is going to return everything back to the pool. But the problem is that when we come to here, when I return it back over, when I get explosion again, my explosion, even though it's set active, is not playing its original clip because the clip is finished playing. And it's not going to redo. There's no loop, right? So I need to access this returned explosion, go back to my animator controller, and play that particular state. I want to go back to that state. And the way to do that is do this. Sorry, it's in one line, but here it goes. Returned explosion dot get component animator controller animator, right, dot play, and then the clip name, the state name, which is explosion, lowercase e, remember? Because that's what we named it inside of our animator controller. If you look at the animator controller, it's called explosion. That name has to match with this name, okay? And this, my friends, will activate that particular clip one more time. So it'll play that explosion clip again. Otherwise, it'll be stuck, invisible, not doing anything. Okay? Does that make sense? Are you with me? Great. Now that we have this, we can exchange the player controller's way of adding stuff. Let's go back to the player controller. And where it says instantiate, we're not going to do this instantiate stuff anymore. This is going to be gone. I don't want to instantiate anything. I already have stuff I want to reuse. And the way I'm going to reuse it is the explosion manager. So I'm going to say explosion manager, and let's make a new explosion. Var new explosion is equal to explosion manager dot get instance dot get explosion. That's going to return an explosion from the pool. It's going to set it as a reference to new explosion, and then what I want to do is my new explosion, I need to do something here. I need to set my explosion itself to where the plane has exploded, which is the explosion.transform.position is equal to the transform.position of my plane. So I want to kind of put the explosion exactly where it's supposed to go, right? Does this make sense to you? So here I'm taking from the pool, putting it in the game, using the explosion. When the explosion is done, it's going to return itself back to the pool where I can use it again. Now there's some stuff we have to prepare in order for me to do this, guys. We're not quite done yet. This is the code. The code is all good. We've done it. Any questions around this? I mean, it should be pretty much self-explanatory to you, and this is how you would do the bullet pool too. If I was going to do a bullet pool, I would set up a bullet pool manager, take a bullet from the pool. Maybe I would have 50 or 100 bullets, however many I would pre-allocate, and then I would use all the bullets one at a time, right? And when I would recycle them, I would just put them back into the pool, use them, take them, dequeue them, unqueue them, all that stuff over and over again. Okay, let's fix the rest. So the fixes that I have to make are the following. Here, great, we are in start, but guess what? We have an explosion container here in start, but not anywhere else. We have to fix that. So, and this is the way we made it. Now, we don't have to do this, but I did it, so it is what it is. One thing is, I definitely want to go to my game controller, and I want to go override, apply all. So one thing is I want to update my prefab. Next, I want to go to the other scenes. So I want to go to scene, and I want to go to my main scene. I want to get rid of level 2 for now. I don't need level 2, just for this example. I want to go to my main scene. So save this scene, go to my main scene, and notice that I don't have a explosion container. I'm going to put that back in, and in my game controller, I definitely want to make a reference to it. Okay, I got to do that, and for my end scene too. So I got to do the same thing for my end scene. So I'm going to go back to my end scene, scenes, and drag and drop a explosion container. Need that in there too. And again, game controller, and we can fix this later, but game controller is going to be put in there. Once I've done this, I can go back to my start scene, scenes, start, and let's try it out. Play. Alright, so a couple things. Do I have my explosions? Yes, I do. Let's move into my start and see if I get any errors. So start. Hey man, what happened to my explosions? What's going on? How come they're not around? Well, a couple things, right? Let's take a look at our game control. Let's see what we're missing. We got an explosion container. That's cool, right? Inside my game controller script, we have an explosion. That's cool, right? So what are we getting? What errors are we getting here? So if I go to double click, it says that when we dequeue, right, that object is not set to reference of an object, right? Explosion manager, get explosion. We're not dequeuing something that is coming from anywhere. Why is that? What do you think that could be? Anybody? Remember, we're doing a singleton, and this presents issues. One thing to note is, what I always like to do is when I go back to my start scene, I always want to update my my game controller, and sometimes that fixes the problem, but it's not this. You're going to see that when I run into a problem, I explode and I'm gone. I got to think about what's happening here. So I'm going into my queue, and I'm trying to get something from an object that is private. Let's make it private and static. If I make it private static, what happens? Am I going to have issues with this? And let me explain why private static. It's kind of a static class in some ways when we make a singleton. If I run it now, still have these, but when I run start, I'm good. And they're pretty good. So I'm getting stuff from the pool. Take a look at this. I want you to take a look at this for a second. And again, okay, that was too fast for me. But let's just restart, and then we'll press this and open this up. Let's take a look at our explosion container. There's a bunch of explosions. And then let's start the game again. Oh, God. I hate when that happens. La, la, la. Okay, one more time. There we go. I want to undo this one, right? Take a look at this stuff. So, one used, gone. And you can see how it moves down the queue. It moves all the way down the queue, and it reuses those things. They don't go down. So our queue is being used nicely. All right? Again, we still have those explosions, right? But now what's happening is they're staying in our queue. They're staying in our queue. And notice the queue lasts on every scene. That's just the way we made it. We don't have to make it this way. For example, I may not need the queue in my end scene or my start scene, right? But I made it so that way, you know, it lasts for everything. And also, we've attached it to my game controller, which exists in every scene. And maybe we only need it on the scenes that we're actively using, but this is fine. Questions about singleton design pattern and object pooling optimization pattern? Yes. Absolutely. So what I changed in the explosion manager to take away that error was I made the queue private and static, so that way it would last between calls. Because remember that what's happening is my game control, my instance is trying to access an instance of a queue that does not exist, never been instantiated, because I never call my start function, right, unless I instantiate it. And this queue needs to be something that persists from one instance to the next. And also, mono behavior is screwing us up. That's why. Okay? Are we good? So we've talked about two patterns. Object pooling, from an optimization perspective, it reduces memory fragmentation, and the Singleton design pattern, which allows us to create a global instance of a particular class that I can access, and so it allows me to reuse my pool right over and over again from anywhere in my code. Okay? A really good design pattern. I highly recommend you use it. We're going to take a short break right now because we're sitting about 3 o'clock, and then when we come back, we're going to be talking about the factory design pattern. I want to make not just one type of explosion, but many different types. How do I do that with a factory? We'll come back and talk about that after. I will put this up on GitHub so you guys have it if you missed it, and we'll go from there.